Hello, hello. So we added GPT-4-Vision support to our RAG starter app a few months ago, and I've gotten a lot of questions about it recently. So I thought I'd put a little video giving a high-level overview of how it works and what it actually means to integrate GPT-4-Vision into our RAG app. So this is the application, and it's from this repo here. And GPT-4-Vision is a special feature. So in order to enable it, there is a guide here about how to enable it when you deploy this repo. So here is a version that has it enabled. And we know it's enabled because on the side in the developer settings, we can see that there's this option to use GPT-4 Turbo with Vision. So I'm going to turn that on. And immediately when I turn that on, you see that the examples change. And that's because we have the sample data for this app. And as it turns out, our sample data for the standard RAG app doesn't really work as well for GPT-4-Vision, because GPT-4-Vision is really good for when you're dealing with data that has like a lot of graphs and images, and our original sample data didn't have that. So here we're using this some finance PDFs that have charts in it, and that's the situation where you might want to consider using a vision approach. So here are some sample questions. So I'll click on one of them, and fingers crossed that it's able to answer it. It's not as consistent as our standard questions. And I've seen sometimes it can't answer it. So we'll find out. So it is going out to try and answer the question. And you can see the other fields I have enabled. So it is going to try and search both text and image embeddings and stream the responses. And it looks like it did get a response this time. It actually drew a little table comparing oil prices and stock market trends, saying there's a moderate positive correlation. And then when we click on the citation, we can actually see the citation is an image. So that means that GPT-4-Vision was looking at this image. And in this image, we see a table. And that's the sort of thing that, it could look at and reason about. So how did this actually work? So I'm going to go to the thought process tab here and look at the process, right? So we got the user query. Then we converted that into keyword search query that we can send to our search index. So then we send that to our search index. And when we send this to our search index, you notice it says vector fields embedding and image embedding. So in our search index, we're storing both text content. So if there was any text in the content, we store it in the text content field. But then we store an embedding for that, right? So these two things are correlated, the content and the embedding, right? So this is the embedding of this text content. And that's what we were able to extract from the image. But then we also store image embedding, and this is an embedding of the actual image. And you can actually see this has a different dimension because we're actually using a different API for this one. So for this one, we're using the computer vision API from Azure. So it has a multimodal embeddings API that can make embeddings of both text and images. And so we use that to do the image embedding, and it has a dimension of 1024. So when we do this search, we actually, we search against both the embedding and the image embedding field to see, because we're looking for similarity between this in two spaces, in the text embedding space and the image embedding space. And it might find that in the text embedding space it's very similar, but not image embedding, or vice versa, right? So we're searching across those two fields. And yeah, so we get back these results. So this is these are the three results that it thinks are the most similar in these two embedding spaces to this query. And then we go and when we get back the results, we're going to send those to the LLM. And so here we're actually sending both text and images. So you can kind of see this here because you can see this data image ping base64. So this is a base64 encoded image. So when you're using the GPT-4-Vision API, let me open it up on openai.com. Let's see. Here we go. Okay, so here you can actually see what the call looks like, where you've got, you know, your question here, and you can actually attach an image URL. Now, this image URL can be an URL, but it could also be a data encoded, basics for data encoded URI, whichever one works for you. So that's what we're doing, is we're sending along these data encoded URIs, and we're also sending along the text. So we're giving it everything we got, right? We're giving it the text, we're giving it the images, and we're saying, hey, based on all this, try and identify a correlation. And then it comes back and it's able to identify it. Now, what's really interesting is that it made a citation to a PNG. Now, how did it know how to cite that PNG? Because in this, we actually never give it the file name. We only give it the image. So it's looking at an image. How do you cite an image? And this is something really interesting that we do, where we actually bake the file name into the image. Let me open this up so you can see here. We put the file name into the image. We actually write it. We're using the Python pillow package to actually write it into the image, and we store it in there, and we've got it stored in, you know, these are all stored in blob storage. So they're stored in blob storage with their file names baked into the top of it. And I think I even have the code open for that, right? So this is the little pre-processing that we do. So we open the PDF reader, and we convert it to an image, and then we use Pillow in order to actually write the text in that top white area at the top, and then we store that. So that is our hack in order to get this citation, because otherwise it wouldn't know how to cite it. And we have to, of course, tell it to use that. So that's in our system prompt. So if we look at here, let's find our prompt. Okay, so what it says here, it says, okay, look at this. Each image source has the file name in the top left corner of the image with coordinates 1010, and it's in the format source file name : file name. And then it also describes how text sources work. So we need to tell it where to find sources. So here we tell it how to find it there. And for the text ones, you know, we tell it that it can find it inside here. So it seems like a lot of effort to get file names, but it's worth it because users really like being able to click on citations and see, oh, okay, that's where you got that information. Let's try another one to see if we see another example. So I'll go ahead and enable it again. And let's see how it does with this question. The impact of interest rates and GDP in financial markets. And of course, this is using GPT-4, and so that can be a little bit slower. So we see that it's basically saying, okay, do not contain specific sources. So it's saying what sources it found, but says it can't make the specific comparison. So it's good. It's admitting that it's unable to make specific comparisons. We'd rather have it admit that it can't make a comparison and give some information than actually try to answer it. Okay, so that one it wasn't able to answer. Let's try our middle question. Expected trend of the S&P 500 index over the next 5 years compared to the past S&P 500 performance. Okay, that's a big question. Let's see how it does on this. Once again, it can be a bit variable. So this is very much experimental, and that, you know, GPT-4-Vision is pretty new. You know, figuring out how to best integrate it into a RAG application is a pretty new thing. This is what we're trying right now. We'd love for people to try it out and see how it works for you, what use cases is working well for, if you have ideas for improving it. So it looks like this answer did actually come through, and we got 2 citations here. And here you can see there's a bar chart. So it's able to, you know, read the bar chart. And we can also look here and see everything that it looks at. So this is everything we sent to the GPT-4 with Vision. These are all the potential things it could look at in order to make its analysis. And now I really want to like upload all my PowerPoints and see how it does with PowerPoints, and if I can get it to like answer based on diagrams, which would be really cool. So this is it. Try it out and see how it works for you. Bye.